Over the last 13.82 billion years, the universe has gone through a number of different phases, or epochs. So here is an approximate timeline of the early universe. 10 to the minus 43 seconds. This time is known as the Planck Epoch. No, not that Planck. Not this one either. The Planck Epoch is the closest that physics can get to the start of time, at the moment. Before this time, everything was a gravitational singularity. Now we think this because of general relativity, although quantum mechanics may have something to say about it. The four fundamental forces of the universe, that is, gravity, electromagnetism, the weak nuclear force, and the strong nuclear force, all have the same strength, and we think were even unified, held together by perfect symmetry. The universe was 10 to the minus 34 meters across, we call this the Planck length, and 10 to the 32 Kelvin, the Planck temperature. 10 to the minus 43 to 10 to the minus 36 seconds. This is the grand unified epoch. Well, the forces were unified, but during this time gravity separates. Gravity was the first of the four fundamental forces to become its own thing. The earliest elementary particles and antiparticles form, and the universe is a hot, dense quark-gluon plasma, which we refer to as quark soup, 10 to the minus 36 to 10 to the minus 32 seconds. This is the inflationary epoch. The strong nuclear force separates, which triggered an exponential expansion, referred to as cosmic inflation. The universe increased in size by a factor of at least 10 to the 26. The quark soup became distributed very thinly across the universe, 10 to the minus 32 to 10 to the minus 12 seconds. This is the Electroweak Epoch. Particle interactions create exotic particles, including the Higgs bosons, which became famous a few years ago when we finally found them. The Higgs field slowed particles down and gave them mass, 10 to the minus 12 to 10 to the minus 6 seconds. This is the Quark Epoch. Quarks, electrons, and neutrinos form in large numbers. Now the temperature has dropped to less than 10 quadrillion Kelvin. The four fundamental forces assume their present forms, and quarks and antiquarks annihilate each other, but there's a surplus of quarks, one for every billion quark-antiquark pairs. This meant that matter dominated, rather than antimatter. 10 to the minus 6 seconds up to 1 second. This is the Hadron Epoch. Now the temperature has dropped below 1 trillion Kelvin. Quarks combined to form hadrons, like the familiar protons and neutrons. 1 second to 3 minutes. This is the Lepton Epoch. After the majority of hadrons and antihadrons have annihilated each other, leptons, for example electrons, and antileptons, for example positrons, dominated the universe. They annihilated each other, releasing energy in the form of photons. 3 to 20 minutes. This is the time of nucleosynthesis. The temperature was now down to 1 billion Kelvin. Protons and neutrons give us hydrogen, helium, and a tiny bit of lithium. 3 minutes to 240,000 years. This is the Photon Epoch. The universe is filled with plasma. It's an opaque soup of atomic nuclei and electrons. The energy of the universe is dominated by photons. 240,000 to 370,000 years. This is the time of recombination. The temperature is now down to 3,000 Kelvin. Ionized hydrogen and helium capture electrons. This is the recombination. With the electrons now bound to atoms, the universe becomes transparent to light. Photons can now travel freely, and we can see them as the cosmic background radiation. 370,000 to 150 million years. This is known as the Dark Age. Whilst photons did exist, there are no stars to give off light, and the universe is quite literally dark. 150 million to 1 billion years. This is the time of reionization. It's the second of two major phase changes of hydrogen gas in the universe. The first major phase change was recombination. During this time of reionization, the first quasars form from gravitational collapse and emit huge amounts of radiation, which reionizes the universe. Most of the universe goes from being neutral to being composed of ionized plasma. 300 million years plus. Star and galaxy formation. Gravity amplifies slight irregularities in the density of the primordial gas, and pockets of gas become more and more dense, even as the universe continues to expand. These small, dense clouds start to collapse under their own gravity, becoming hot enough to trigger nuclear fusion between hydrogen atoms, creating the first stars. Stars form galaxies, which form groups of galaxies, clusters, and superclusters. And we have our universe.
Hey you, hit the like button. Yeah, and the subscribe one too. Yay!